All right, so I just have one more little video here just so you guys can see more solving by factoring. We know we've talked a little bit that we need to make sure the equation is equal to 0 first and that it's in standard form. So meaning that our x squared goes first, our x in the middle, and our third term by itself. We factor the equation. We're going to make sure we check for our greatest common factor. And then we set each factor group equal to 0 and we solve that way. So we've done this already a little bit on your homework, which is going to be on Delta Math. The first two problems, I think, all you have to do is make sure the equation is equal to 0. So we'll go over that here in just a second. So then, looking at our first example, let's just kind of get right into it. We need to, so is the equation equal to 0? So we can see in this first equation that yes, in fact, it's equal to 0. So we're good to go on step 1. So now we need to work through step 2, factor the equation. We do want to factor a greatest common factor if we can to make the values smaller. So is there anything that we can see that all three of these numbers have in common? And in fact, they all have a negative sign. So we could take that out, which makes it easier to factor, and they're all divisible by 2. So that's basically what a greatest common factor is. So we know negative 2 times, and this would, if I divided this, would give me h squared. 28 divided by 2, this would be a negative over a negative, would make a positive 14h. And 98 divided by 2, that would make this a positive again, would make this 49. So there would be our greatest common factor taken out. We took out the negative 2. I didn't really get rid of it, I just factored it forward. So now I'm going to factor this. I'm going to do the first term times the last term. So that's going to be 49h squared. And then has to add to make 14h. So what could multiply to make 49? Well, that's a nice easy one. That's 7 and 7. And 7 plus 7, sure enough, does add to make 14. So I need a positive 7h and a positive 7h. And then we put in our first term in the first box, our last term in the last box, and we can factor it out. So that would be h times h makes h squared, plus 7 to make 7h, another plus 7 to make 7h, and then we still get our 49. So in factored form, I should bring down that negative 2, and then I have h plus 7 times h plus 7 equals 0. And so then to solve this, I'm just going to set them both equal to 0. Now, if you notice, technically, I'm going to put all of my factors equal to 0, but the first factor, negative 2 equal to 0, that doesn't really make any sense. Negative 2 does not equal 0. There's no h to solve. So I don't really need that negative 2. But I can solve for h here. So I get h equals negative 7. And if you notice on the second equation, I get another h equals negative 7. So it's the same answer. That's okay. You can write the same answer twice. There's one solution that is, there are two solutions, but it's identical to each other. So that would be our only possible value. So the only number that would make this equation equal to 0 is negative 7. Okay, so now let's solve by factoring. Where we have our equation, notice this time it is not equal to 0. So we need to make sure this is equal to 0. So I'm going to subtract the 1. And since I look over here to my other terms, I see the 16 matches. So your first two problems on your homework tonight are going to be just like this, where you only have to make it equal 0. You don't actually have to do anything else. So that's all I'm looking for is, can you get the equation equal to 0? And then the next, I think there are 6 other problems are where you're just solving it then. So that's what we've been doing. So now we look through here, is there anything that all three of these have in common? Well, 12 is like 4 times 3 or 6 times 2. 28, 4 times 7. So they've got a 4 in common, or 14 times 2. And then 15 is 5 and 3. So 28 does not have a 5 or a 3 in it, no matter how you split it. So this has no greatest common factor. So now what we're going to have to do is the first term times the last term. So I need to do 12y squared times 15. And that's going to give me a really big number, which is actually okay. It's going to give me 180y squared. And then the middle term is our negative 28y. And since I can see I have a negative, I need, and they multiply to make a positive, I know I need two negatives. A negative times a negative makes a positive, and I have to get a negative 28. So what numbers will make 28 from 180? And obviously there could be a ton of them, but there's one that jumps out at me right away, and that would be, I can see it, 18. 18 times 10 makes 180, and sure enough, 18 plus 10 makes 28. So even though the numbers are really big, I try to make them obvious when they're big so that you can see or quickly factor that out. So there's our two values, minus 18y and minus 10y. Our first term then will go in the first box, so our 12y squared, and our 15 goes in the last box. So we're trying to undo this factor. So we know we're going to need a y and a y, and I need to break up this 12. Now 12 does not go into 18 evenly. 12 does not go into 10 evenly. So I can't just put 12 on the top or on the side. I need to break the 12 up. 2 goes into both 12 and 10. And 6 goes into both 12 and 18. And 6 times 2, sure enough, does make 12. So then 6 times what makes negative 18? I would need a negative 3. And 2 times what makes negative 10? I would need a negative 5. And then we can just double check. Does negative 3 times negative 5 make positive 15? Sure enough. So those are our factors then. This one was a little trickier, but it's not impossible. And there's our factored form. So now our question is, if we factor it, can we solve it? So can I take 2y minus 3 and set it equal to 0, and 6y minus 5 and set it equal to 0? And we can, and we should, and then we solve. So the first one, if I was to solve this, I have 2y equals 3, and then I would divide by 2. So I get y equals 3/2. There's a solution. In the second one, I would add my 5. Yep. And so I would have 6y equals 5, and then I would divide by 6. And that would give me y equals 5/6. And there's my two solutions. So it's not a pretty answer, but it is an answer. I factored everything, and I could always plug this back into the equation and make sure it's right. So I just have one more for us, just to double check. Notice this one's a little crazier still. It's not equal to 0, and I can't even add the 11 over because there's nothing to add it with. But I've got parentheses, so I could see here, I'm going to have to distribute these parentheses. So notice I have a negative 10 that's going to get distributed, so that's going to make this a minus 10x. And then I have to do negative 10 times negative 1, which makes positive 10. And now I need to make this equal to 0, so I'm going to add my 11. So I have x squared minus 10x plus 21 equals 0. So I had to do a little bit of extra work. But now I think I've actually factored this one, or I've been very close. First term times the last term, I've got 21x squared. Middle term is a negative 10x. So 21 is 7 times 3, and they have to both be negative in order to give me a negative 10. And so now I would factor this. I would put my negative 7x and my negative 3x in the diagonal corners of the box. My first term is my x squared. My last term is my 21. And what could factor to make this work? Well, I know I need an x times an x. I'd need a minus 7 and a minus 3. And so then my factored solution, x minus 7 times x minus 3 equals 0. So what would it look like as an answer? What would x actually be using our zero product property? Well, I could add my 7 to 0, so I would have x equals 7. Or I could add my 3 to 0, and I would have x equals 3. So 7 or 3 are my two possible answers that makes this work. That's all there is to it. I have on the paper notes, I have some more my turn, your turn, just so that you can see more examples, but I think these three should probably get you to it. It's really just moving your numbers, making sure you have it equal to 0, and then factoring from there. So always check for a greatest common factor if you can, and then do your diamond and box if you've got 3 terms, and set them all your factors get set equal to 0. So good luck. Homework's on Delta Math, and I will see you on Monday.